Okay, so this is the circle dot. It's a section of a cone flattened to become just an area, so that if you can shape that into a cone by overlapping it, so you're overlapping the sections, overlapping it, making a cone. If you overlap more and more and more, you get a cone of tighter dimension, but the length remains the same. Assuming this length is infinite, and you wrap your cone, and you took a section of the cone, it would look like that. It would just look like a tube that would be solid. If you assume that the paper is so thin it actually has no mass, but that it's motion, it's in motion, so it's creating this spiraling chirality, it's inside, you end up with, looks like a straight tube with a diameter the same either end. Now that's because it's existing in time, it has a duration. So what you're measuring in the cone is that because it's infinite length, you can't measure infinite length, but you can take a section of that cone and it will look like that. It will look like a straight line. But you could then unravel that cone from this perspective, unwind it, and you actually find, no, it is a cone. It does have a starting surface area, a dot point, and that the surface area that it is in fact related to its length, but must include all the spiraling as well as inside it, because it's the expansion that's actually creating expansion of the light that's creating this spiraling and the beam itself. So you must include the duration now when you're working in infinite length. So what that means is when you unfold your area, you get, what I was trying to show was, you get an overlap, that they don't line up, that there's an overlap. And so if you then try to make a cone out of the overlap, you can't. The paper is going to get distorted. You can't do it. You put that extra, if you see what I mean? There's the single one. If you had an overlap, I've got two bits of paper to represent that. You've got an overlap. You then try and join the overlap together. You just distort this. You distort the area. It's distorted. So the only way you can accommodate this additional duration into the surface area of the light is that you have to bend this area. This area must exist with a shape into it. You've got to, each particle of this shape must be adjusted so that it fits into a bend. So the relationship you get is this, where you've got a bend in the top surface, and then a straight line is created underneath it. So it's the overlap in the duration of existence that creates this tension between two areas, inside and outside. And that if you've got when you think about this as a cone, you've assumed a cone, straight line, taken section, then you've come back and opened up that cone and analysed it. You've discovered this duration, and then you've used Dr. Lebe to understand that the duration is the duration of the twist and the untwist of anti-clockwise and clockwise nuclear force, Dr. Lebe 1915. You add that information into this, and then you can see, it's not a cone, it's a section of Gobiel's horn. That you have, because this surface is this shape, but it's that way up. So the dent of the meter square is actually into the straight line. So the outside curved surface and the inside straight line are actually the wrong way up. The tension in the force in the contractive force of the straight line at either end, as the tension tries to bend, as the expansive force of the light moving in that direction, which creates the beam, creates an expansive force. That expansive force creates the surface area, creates a dent in the surface area. And that dent in the surface area is now the mouthpiece of Gobiel's horn. And so Gobiel's horn goes off in this direction. So what we're saying is that, and so you can see that the rolled up tube is in fact a section of Gobiel's horn. Gobiel's horn has an infinite volume, but a defined surface area. If it has a defined surface area, it has a defined inside and outside surface area. You use pi natural for the inside, pi real for the outside. So that the dent here is caused by the infinite acceleration of the light going off in the other direction. It's that the drawing of Gabriel's horn I did, where it just goes round and it's actually poking in, it pushes up. There's the paradox. So you've got a contractive force from expansion with a tension which resists it, and you've got a tension force with a contractive force that resists it on the edge of the sphere. But what you end up with on the outside of the sphere is a contractive and attractive force towards the center, and it's called gravity. It's called gravity. And it's as easy as that. It's just surface tension being stretched, and you explain it mathematically from a dot point and a straight line. Fundamentals, Kaylee, isn't it? It's just fundamentals. And we're about to stand on a world that Tversky promised us of anti-gravity. Watch. Just watch what's going to happen. Welcome to the future. Follow the Rebel King.